Hello guys. Want to make a couple of videos for y'all so that you can review your factoring rules because some of you struggle a little bit with factoring. It's one of those invaluable things in algebra. So if we break it down, there's several different kinds of factoring. I'm going to make a different video for each of the kinds. In this video, we're just going to talk about simple factoring where you factor out a common term. There are several other kinds. You've got the difference of two squares. You've got perfect square trinomials. And then you've got the two different versions for if you've got ax squared plus bx plus c, where a is equal to 1, and then you've got the version where a is not 1. So basically you've got a coefficient of x squared that's not 1. Those get a little bit more complicated. Then for Algebra 2 and Algebra 3, where it gets a little bit more advanced, there's factoring by grouping, or if you want to use the word chunking, we can do that. And then there's the cubes, so the sum and difference of two cubes. So we got several little things to look at, but for this particular video, let's look at factoring out a common term. Now keep in mind, when you're factoring, what you're doing is you're taking a polynomial, and it's kind of like you're pulling it apart. So where you would have distributed earlier, like if you had 5 times x plus 2, you should know how to distribute that. If you say 5 times x is 5x, and 5 times 2 is 10. Well, all factoring is go in the opposite direction. So if you look at your numbers, your coefficient, your constant, you see, okay, what is the biggest value that goes into each? Well, that's 5. So we're going to take 5 from both of these terms. If you divide those two, 5 divided by 5 is 1x, and then 10 divided by 5 is 2. So you can easily check your work by distributing it out, either distributing and later we'll FOIL it out. But you're looking to see what's common, and you want the biggest common value. That means that you have completely factored it. So if your instructions say completely factor, that means you need to pull it apart until you can't pull it apart anymore. It works with constants or with the numbers, and it also works with the variables. So if you wanted one that just had variables, think about x squared plus 3x. Both terms have x's. Now, think about it like this. You're taking up a collection from every term. You want to take the same amount from each term. So you're restricted by the one who has the least. So the smallest exponent, this second term, that guy only has 1x. That's all he can give you. So that's what you're restricted to, your smallest exponent. Now you just go around and you collect that same amount from every term. This first guy, he had 2 x's, you took 1. There's 1x left. And then you bring down your 3. He had an x, you took it. So there's nothing back here. You can obviously check it if you wanted to. X times x is x squared, and x times 3 is 3x. So you can do them separately. You can also do them together if, you kind of have to see what your problem allows. So if we had 9x squared plus 3x, you need to get in the habit of checking out your numbers. Is there a number that goes into both 9 and 3? If so, you want the biggest one that does it. Well, 3 is it. Now, look at your letters. Does everybody have the same letter? If the answer is yes, then you go through and you say, all right, let's look at the exponents. Well, my smallest exponent was 1. So the most I can take from everybody is 1. So you're going to put your common term out front, or your common factor is out front, and then you're going to divide every term. So if you start with a binomial up here, you're going to have a binomial in your parenthesis down in your answer. Divide your numbers, subtract your exponents. 9 divided by 3 is 3. He had 2 x's, you took 1, so there's 1 left. Bring down your plus sign. 3 divided by 3 is 1, so you can put the 1 if that makes you feel better. And then x, he had 1x, you took it, so there's none left. So in this case, you really need the 1. because you can't go from being a binomial to a monomial. You have to remain the same size polynomial. So if it starts binomial, it's got to be a binomial in here. This 1 acts as a placeholder. So when you come back and you multiply, you get 9x squared, and you get 3x times 1. There's your 3x. If you don't put the 1, you lose that 3x. So, personally, I think that the small problems like this are tougher than the larger ones. Let's see here. If we've got 5x to the third plus 10x squared minus 15x. Let's just do a little practice. Look at your numbers. Is there a number that goes into all three? Yes, there is. The biggest one is 5. Now check out your letters. Everybody has an x, but the smallest exponent is 1. So that's what you're restricted to taking. Now divide your numbers and subtract your exponents. 5 divided by 5 is 1. He had 3 x's. You took 1, so he's left with 2. Bring down your plus sign. 10 divided by 5 is 2. Subtract your powers. He had 2, you took 1. He's got 1 left. Now move to the next one. Do it again. 15 divided by 5 is 3. And you took his x. He doesn't have any. So you're finished. That's your answer. Don't think that you can always do it. Sometimes it's just a mess. If you got 15x squared plus 18xy minus 21y squared. Check out your numbers. Can you take 1? Well, we've got 15, 18, 21. The biggest number that goes into all three is 3. Now look at your letters. The first two have x's, but the third guy doesn't, so you can't take any. Then when you look at your y's, well, the second two have y's, but the first one doesn't, so you can't take any y's. All you can do is the number. So you would go in and divide the numbers, leave your letters the same. They don't change, only the number does. And so that is completely factored. You cannot pull that apart anymore. As I was saying, the really big ones, they look intimidating, but in all honesty, I really think they're easier. Let's just make up one and see what we can do. Okay, so we got this problem. Looks kind of intimidating, but do it step by step by step. If you check out your coefficients, you have 20, 15, and 25. 5 goes into all of them, so that's part of your common factor. Now, just look at the m's. For the m's, we have a 3, a 4, and a 5. Smallest power, he restricts you right there. You can only take 3 m's because that's all the first term has. All right, go to the next letter. Does everybody have 1? Why, yes, they do. But your smallest power is down here. It's a 1, so that's all you can take. For your p's, everybody has 1, but the first guy only has 1. Once you've figured out what your common factor is, you can go in, divide your coefficients, subtract your exponents. So 20 divided by 5 is 4. He had 3 m's, you took them. He has none. He had 2 n's, you took 1, so he has 1 n left over. He had 1 p and you took it. All right, you're done with that term. Bring down your plus sign. 15 divided by 5 is 3. He had 4 m's, you took 3. There's 1 left over. He had 5 n's, you took 1. He has 4 left over. He had 2 p's and you took 1. He has 1. Bring down your sign and start over. You see how this is kind of repetitive? So once you get the skill, you should be good. 25 divided by 5 is 5. He has 2 m's left. You took all his n's, and he has 3 p's. Okay? You should be good to go on factoring out common factors.